Okay, so today we're going to be reviewing quadratic functions written in standard form. This is a lesson that you guys have already learned before we went on break, but we are spending the time to come back to it today. This is something very important that you need to know for our lessons moving forward. So quadratic function written in standard form looks like this. We have f of x, our function is equal to ax squared plus bx plus c. This is a model that shows that functions in standard form have an x squared term plus bx, the second term, plus c, a constant value. This is represented with variables and is often how you'll see an example of standard form being written out. But to kind of show you guys what it would look like with numbers, it would look like something like this. So we have the x squared term, ax squared, plus 2x, our bx term, plus c, our constant number. So just how c is our constant number, there is no x variable on this last term here. So this is generally what standard form looks like. Now, what we need to also quickly look at is what do the values mean written in standard form. So in looking at the physics of it, the science of it, quadratic makes a U-shaped graph. It's like a parabola, okay? This is the kind of shape that's modeled when we throw something up into the air and then it lands. So this is also something we've learned already before today, but in reviewing this is another example of a quadratic written in standard form. We have negative 16t squared plus 23t plus 4. What do these values mean? So in this case, the negative 16t squared represents the gravity. The 16t squared here is the value for gravity. Then the positive 23t represents the velocity. So in this scenario, the object was thrown up positive at a velocity of 23. And lastly, it had an initial starting height, our constant value. Our initial starting height is at 4. So on a graph, if this is looking like a graph, it would have an initial starting height of 4. My graph's a little off here because it looks like it's starting at 0. But with a value of 4, it would have a vertical intercept, an initial starting height of 4 when it's thrown into the air. Okay, so now coming back to what a quadratic really is, written in standard form, there's a few key features we need to be reminded of. First, it must have an x squared term. So in this case, an example is 2x squared plus x minus 6. We have the x squared term, thus it's a quadratic in standard form. I see the 2 as an exponent. Second, it does not need all three terms. So all the examples we've looked at so far have 1, 2, 3 terms, 1, 2, 3 terms, but it does not need to have all three terms to still be considered standard form. Here we have x squared plus 1. We don't have a bx term. We don't have a term in the middle here with a regular x on it. That is okay. It is still standard form because I see this x squared piece. And lastly, the order doesn't matter. Another example is 4. We have our constant value minus 3x, our b term, a value just with a regular x on it, and plus x squared at the end. Again, this is still a function, a quadratic written in standard form, because I see that term with x to the power of 2. All right, so moving on. Every quadratic in standard form is equivalent, meaning the same as a quadratic in factored form. Equivalent expressions mean the quadratics are the exact same. Even though they appear to be written in different formats, they are the exact same expression. They're equivalent values. We can expand a quadratic in factored form to see if it's equivalent, to see what its equivalent expression in standard form is. So, if here we wanted to figure out, okay, what is this quadratic's currently written in factored form equivalent standard form, we would use what we learned from last lesson and multiply those out. So here I'm going to take 2x and I'm going to multiply it by x, distribution property here. So then I'm going to have 2x squared, x times x is going to be x squared. Then I have 2x times this 4. That is now going to be 8x. Then I'm going to take the second term in my first factor and multiply it by the first term in the second factor. Negative 1 times x is just negative 1x. And lastly, I have negative 1 times 4. Again, you must include the sign. Negative 1 times 4 is going to be negative 4. Now I need to combine like terms. I have 2x squared. 8x minus 1x is positive 7x minus 4. So here, I know that this quadratic in standard form is equivalent to this quadratic here written in factored form. At first glance, they might look very different, but you can verify if they're equivalent to one another by expanding out the factored form and seeing if it matches the standard form. All right. The last part of this video here is if we're looking, equivalent expressions are the exact same. We already know that even when written in different forms. So again, even when they look differently, it's very important to expand out using the box or distributive method to see if a factored form and a standard form are equivalent. That way you have them in the same form to accurately compare. And thus, when they are equivalent, they have the exact same graph. So again, a quadratic graph is a curved graph. It makes a parabola. And a quick reminder is intercepts. Intercepts are the points on a graph where the points cross the axes. So here's my y-axis. I'll go ahead and label that for us if we need a reminder. And then we have our x-axis. Our y-axis is the vertical axis. Again, vertical means going up and down. Our x-axis is the horizontal axis. So again, side to side, like when the sun sets on the horizon, that's your horizontal axis. So in this case here, this parabola has a vertical intercept at 0, 1. Vertical intercepts on the y-axis always have an x value of 0 because here the x value is literally 0. So if I had to label this coordinate, it'd be 0, 1. So 0, 1. Here I have a horizontal intercept. I go over x value first. X is at 2, and it does not go up into the graph at all, so the y value is 0. So in an x-intercept, the y value is always 0. What you guys are going to do now are some practice problems. Please feel free to come watch parts of these videos again if you need some help, and you are going to go ahead and answer the questions on the next slide.